Hey, happy Sunday. This is PFG Live, the podcast that gets flat, stays flat, and likes it. Welcome aboard, everyone. Let's see. We got a couple of guys. Evils is here from Ghent, Belgium, where he reports it's 20.3 degrees Celsius, 11.5 degrees dew point, and a bunch of other numbers. Bill Olney from Rome, New York, home of Air Force Research Labs, says it's 45 degrees Frankenstein and raining. Let's see. Josh is with us from southern Manitoba, where he reports it is winds 340 at 11, gusting 17, temperature minus 04, dew point minus 06, with a peak wind of 20 knots. Holy cow. Emmanuel is reporting 8 degrees science, 80% relative humidity in Zurich, Switzerland. Welcome aboard. And Tucker in the great Buffalo, New York, is reporting 35 degrees Frankenstein and snowing, with a great picture of his kiddo. Thank you, sir. Let's see. I'm going to jump over to YouTube. CJ Stevens reports 68 degrees and sunny in East Tennessee. No snow yet. And here in Windham, New Hampshire, we're reporting 52 degrees Fahrenheit, 80% relative humidity. And let's see, winds out of the east at 9 miles per hour. Paul Morley is in North Texas, where it is 51 degrees Frankenstein. Arstead is with us. Welcome aboard, sir. 32 degrees Fahrenheit and windy in Peoria, Illinois. Dale says it's 3 degrees science, mostly cloudy in the far north. Yes, it is. Who do we miss? Let's see. Tim Beatty is with us. Welcome, Tim. He says it's 80 degrees and sunny in Phoenix, Arizona. Of course it is. Of course it's sunny. Let's see. Ted Hyde is with us from Casa Frog Pro Resources in Eustis, Florida, where it is approximately winds are 200 at 4 knots, visibility 10 miles, broken at 1,000, overcast at 3,000, temperature 26, dew point 23, altimeter 2996. Remarks, hoodies tomorrow for all. Yeah, it's going to go down, isn't it? Well, let's see. Manchester Airport says winds are variable at 5 knots, visibility 10 miles, overcast at 1,200, temperature 08, dew point 04, altimeter 2993, with some remarks. There's a reason it sounds like an ATIS report, dude. Please report that you have ATIS information Foxtrot for flat. Welcome aboard. I don't know, Tim, if you're getting a sense that I've spent a little time behind the stick, you would not be incorrect. And welcome to all of our YouTube. One of these days, you YouTube guys are going to beat the Discord guys in weather reports. That was not today. Welcome in the Discord. We have Josh, Bill Olney, Evils, Carl Tauber, Defrach, and I don't recognize your name, Dale, Tucker, Paul, Emmanuel, Ted Hyde, Arstead, and AJF. Defrach is in Westchester, Pennsylvania. I know where you are. Winds are 180 at 6 knots, altimeter 2971, temperature is 62 degrees Fahrenheit, 17 degrees science, relative humidity of 83% with visibility of 5. It doesn't matter what 5 what, it's 5. Welcome, sir. Westchester, Pennsylvania is also glider country. So, yeah. Let's see. So, happy Sunday. I hope you guys had a wonderful week. It was, yeah, Evils cracked the Bundaberg open, as is correct. We need a sound clip of a Bundaberg opening. We don't have one. So here's some PFG Stones. Okay, enough of that. Busy week. A lot of interesting things going on. I had a bunch of stuff in the antenna world happening that I cannot talk about this week, but there's stuff I can talk about. I went up to Maine and I helped my buddy Steve. We were doing a bunch of antenna improvements on his property. Let's see if I can get I get a nice picture of Steve here. He won't mind showing off. There's Steve up at tower. And Steve has a magnificent horizontal bow tie antenna, and we just put up a 80-meter dipole. He has a 40-meter dipole, and this little tower is sort of the centroid of all those things. And there's more stuff coming. But hey, thanks, Steve. That was a lot of fun. And we had clams at the Clam Shack up in Maine. I mean, when in Maine, right? And that was significantly yummy. So yeah, that's what's going on. A lot of other stuff, and we've started lapping. We're going to talk a little bit about lapping, getting our 8-inch laps conditioned in and ready to work. That happened this week, and we're on. I don't know how many rounds we've gone on the laps. We'll talk about that in more detail, but it's going pretty well. And living a balanced life, we're going to talk about that. Not what you think, but it's what you think. And whatever else you want to talk about. It's a pretty laid back session today. I don't have a ton stored up for you. So we'll see what happens. Let's see, Mr. I got to ask the question earlier. Did he just... Oh, there's Carl. Carl asked me, when does the snowometer go outside? And the snowometer usually goes outside when we get the first flakes, present company not included. So we haven't had them yet. We haven't had one snowflake yet. So you will be the first to know, I promise, when the snowometer goes out there. Tucker, we don't do we have a live video report from you to show the current weather conditions, or are you done with that? Tuck gave us some live video. Here he is. Hang on. I'll get you up here. Please welcome Tuck. Look at that. Snowing in Buffalo, New York. There it is, live. We're doing it live, folks. It is currently snowing in Buffalo, and that's awful. it's awful. It's the first snow on the PFG.Live for the season, so you definitely earned it. Good job.
No, it is collecting. It is wet. It is awful. I am putting away air cushions because I forgot to do that, and I'm lazy.
Okay, fair enough.
So, right. Fun.
Okay, thanks. Well, it's winter, or it's about to be, so we have to live with it. Josh says the shipment from the West is en route. Yeah, so Canada is sending us snow via... how's it coming, by the way? Is that an LTL shipment? I just want to make sure we... Air. It's coming by air. Okay, that was the best answer you possibly could have given. All right, very good. Well, cloud drop. Yeah. I'm not looking forward to it, but I did get new tires. I think I talked about it on the last live. So we're going to test some new tires in the snow. We'll see what happens. Yeah, I should get the link shortly to the cloud drop. It's coming. We have been using the heat in the shop for sure. That's been going on for a little while. And we cleaned up outside the shop doors. No, Tim suggests that we make the tires flat. We do not want the tires flat. There are things in our lives which we want flat, and tires are not amongst them. However, what do we want from our tires? We want them what? I'll give you a hint. We want our tires. Come on, you guys could do this. Random. We want our tires random. Exactly correct. Thank you, Evils. No. We want our tires balanced, right? Fringed. They could be fringed, although a lot of you are on the fringe. Concentric. Actually, concentric is a pretty good thing. Can we use a balancing ring? Yes, you can. We want them true. Also good. So all these things we go through with grinding wheels, we already know about. Full of moly. I don't know if that would do us any good at all, Ted. Although, if any of you follow some of our favorite nerds on YouTube, like Veritasium, you'll learn about there are some tires that have beads in them, like bearings. Also, Steve Mould, right? Mould, mold. There are tires that have beads in them, and they self-balance as they spin up. And there's, you could say, wow, that sounds like a great idea. Why don't we do that for grinding wheels? Believe it or not, there are hubs that have that stuff in them. And there's pluses and minuses. I don't think it's a great idea. But if you wanted to balance a grinding wheel, you would basically do it the same way that they balance tires. Now, if you've bought tires lately, you might have watched your tire person. Yeah, Tim got it. You might have watched your tire person balance your new tires on your rims. And they're doing a couple of things, right? Paul says we're getting a tire machine / balancer at our makerspace. I've always wanted to be able to change and balance your own tires. That is really cool. I like it. Some of them do dynamic balancing, right? So they'll spin the tire and they'll measure the wobulation and the vibration, and they'll display, turn the machine till this says a number, and that's where you want to put this amount of weight, and that works. Okay. There are products out there that will do that for balancing wheels. I've had some conversations with the gentleman who is working on a product to bring to market, and it will do that. Now, that product, when it comes to market, is probably going to be a $2,000 to $3,000 product, which is pretty good if you're familiar with the grinding world. If you have a fancy $500,000 grinder, you could get an option that will just balance everything for you through different means. So we're not going to dive into that too deep, but it's expensive. On my grinder, on the Okamoto grinder, when I bought it, I was able to get an auto balancing option. I think it was on the order of $20,000 to add to the grinder. It was like, no, thank you. Josh says, do you mill pockets in the tire to balance, or is it with a screw that you adjust? So in the old days, we had these, and it's still done. I should have brought some up for this. I didn't realize we were going to dive into this. But there's a lead weight with a little clippy dookus, and the clippy dookus was the right shape to go onto the rim of the tire, and they would use a little hammer and put them on there. So that's a really good question. All the balancers and balancing methods that I've seen, Tim, are assuming it's a two-dimensional. A one-dimensional system. Okay, so some of them, and I think some of the machines, like if Paul is getting a fancy machine for the makerspace, that they will also do. They'll feel the wobble, and they'll give you two-dimensional. It's really three-dimensional balancing, right? Dale says fancy tire balancing machines do road force as well. Do they put an idler wheel? Single plane. Thanks, Robin. Okay, so apparently they put an idler wheel on the tire and simulate the road. That's fantastic. That's great. Robin, can we put an idler wheel on our grinding wheels to simulate the tool, the grinding load? That would be good. Oh, Carl, that's a great idea. We should invite Cash Masters to talk about balancing grinding wheels. Yeah, but Cash Masters grinding wheels are the size of my house. So while it is proportional and similar, it's different. That would be pretty cool. Yeah, Robin and I go way back talking about balancing, and we've talked about various things. Some of the balancers on grinding wheels, between centers part with no drive. So, in a grinder that has a balancing function, one of the things that I've seen is a little, for lack of a better term, a little pecker that comes out and pecks the wheel to remove a few grains as it goes around. So it's got some pretty fancy stuff going on in there. It has an accelerometers, and it knows the position of the wheel, at least with a synchronization point. And as the wheel goes around, it makes a measurement, and it decides where it wants to peck. And then as it comes around, it goes peck, and it takes out a little teeny bit of mass, and then it checks it. So this repeats until the balance is within tolerance. Another good podcast, by the way. I see what you're saying. So Robin is saying you could take a part and put it between centers, and you could balance as you grind. This is very fancy. I like this. So that's one of the methods, is to peck the wheel with a little pecker that in a closed loop system that will bring the wheel into balance. There are other really fancy hubs that literally put the wheel, will move the wheel around on the axis of rotation. And if you think about what it takes to do that, it's pretty crazy. But there are systems that do that. I have no personal experience with those, but that is a pretty nifty thing to do. And think about, you balance a wheel, and then you go and you true a wheel. Well, is it in balance? So now you go and you balance the wheel again. So then you go to grind with it. Well, now you've worn the wheel. So it's this constant loop. Tucker reports, fun fact, Starrett sells specific tire measurement equipment made for tires. I didn't know that. Did anybody know that Starrett sold tire instrumentation? I had no idea. Yeah, and Tim correctly points out, and then you crash the wheel. But hang on, before you crashed, it was magnificently balanced. There it is. An online profilometer enhances the extrusion quality with real-time non-contact laser measurement for tread and sidewall profiles. You might already be rolling around on something that was measured with a Starrett instrument. That is crazy and wonderful at the same time. There it is. Oh my God. I love this community. Bitewise. Is that what they call it? Bitewise is the name of the product, apparently. And Tuck says that they were used at his old place of employment. That is pretty neat. So the fact that as you grind, you balance a wheel, you grind with the wheel, and now you're wearing down the wheel. So now it's a little bit out of balance. So you really should go back and balance it. You realize that it's a never-ending process, which means is the wheel ever perfectly balanced? And the answer is not really. If you are a good grinder hand, and you balance your wheels and you true your wheels and you dress your wheels, repeat, then you get some pretty spectacular results until you use PFG Stones. And then they start showing you all the places where that's not true anymore. Now, the fact is that it's just like all of our tolerances, all of the acceptable deviations from perfect, or as Adam Savage says,
perfectly.
We accept a certain amount of that. And the name of that, I guess we call that residual imbalance. That imbalance that you just can't get rid of it. It shows up in the work if you look for it, and if you don't want to see it, you get out the gray Scotch-Brite and you just rub it, and what do you know? You can't see it anymore. Some of the things that you can see, that's true. Evils points out that the word balance can mean residual. Thank you, Evils. Robin says, oh, here it comes. Saying perfectly anything means you lack instrumentation with sufficient resolution to see the imperfection. What Robin is trying to tell you is get a better indicator. And he's completely right. We'll grind things and it looks great. Then you hit it with the stones and it's like, okay, I see a couple of things there. And then you improve things, but there's a limit, and you know what your limit is for the job that you're doing. So here's what not to do. What not to do is to listen to these old conversely, Josh says anything can be perfect if your standards are low enough. Thank you, Josh. So understand how good your stuff has to be, because otherwise you're going to either throw away time or throw away money and bring it into tolerance. So if you're a guy with or gal, I'm sorry, that's a non-gendered term. If you're a machinist with a grinder and you're enjoying your Harrig 618 or 612 or whatever, and you've heard the old timers say, those small machines, you don't have to balance them. You don't have to balance those wheels. Don't bother balancing the wheels. Well, to that I say, and I say this with a kind heart, bullshit. So, it's amazing how out of balance off-the-shelf wheels are. I got a call or an email from one of our customers, and he said, hey, I love your balancing stand. By the way, that's the number BS8 balancing stand, available at PFG.Stones.com. And he says, but we have this wheel and we've put all the screws in the kit, plus the mounting screw, which is brass intentionally, on one side, and we still can't get it to balance. And I'm like, yeah, that's because there's a lot of junk out there. So one of the things that I advised him to do was to loosen the wheel and move the whole wheel in that direction in the light side, and then retighten everything up and try again. And then it's a process to make up for the imprecision of the manufacturing process, because sometimes they come in and they are really out of balance. Let's see. Paul says, would balancing a grinding wheel in space be more accurate / easier? So now I'm thinking, let's see. Depending on how I answer this, I could improve the chances of getting a ride to space. No, it won't. It won't do anything. Out of balance is out of balance. It's a chunk of, okay. I didn't want to go too deep in this, but it's too late. Imagine a disc, perfectly balanced wheel, okay? And you walk up to that wheel and you take a binder clip Okay, you take a binder clip and you clip it to the wheel. Okay, so now it's out of balance. It doesn't matter if you're in space or not in space, right? But you can model the out of balance condition as a chunk of mass at a distance from the center of the disk. That's it. And your job is to make that chunk of mass do one of two things. Either move to the center of the disk or have the mass of the chunk go to zero. They're both the same thing. It's both a moment arm. It's a mass times a distance from the center that you want to be zero. And that's what the goal is. And then you have a balanced system again. Yeah, Evils, I don't think deformation from resisting gravity is going to, make our lathe compound work any better. Dale says sometimes cheap wheels don't have very parallel sides, which can make balancing an extra pain. So on the PFG, on the Kinetic Precision website, I'm trying to remember exactly where it is. I think it's in the balancing ring product information page. There's a picture of me bringing a green wheel into balance, and that wheel was a complete wobulator. And as I dressed the side of the wheel, and it was like it was crazy. So you can't make any assumptions about the wheel. And if it's wedge shaped, right, instead of being parallel, then the fat side of the wedge is going to be heavy and it's going to be out of balance. Is the problem balance or is the problem parallelism? Both. Interesting. Tim says wheels that deform under their own weight would do better in space, which is to say, not that they're a superior thing to choose whilst in space, but we should shoot them to space. Robin, I will invite you to come on in here. Hang on a second. What point do you true the side of the wheels? The answer is I always true the side of the wheels, but that's another story. Mr. Robin Renzetti, I believe you are live. There you are.
Just something to think about relative to space is if you take a disc in space and obviously it's weightless and it can just float around, and you spin it with, let's say, two tangentially opposed air blasts in order to spin it. You would need to do that for it to not just run away from the air blast. So ideally, if you had two tangentially blowing blasts 180 degrees apart,
yeah,
you could get it to spin. Well, there's no imbalance in that case because it's inherently going to spin on its center of mass.
On its natural axis. Right.
Right, wherever the center of gravity is. And keep in mind, it wouldn't necessarily spin in the round direction. It could spin any direction because the center of mass is a single point. So it could spin sideways perfectly fine. If it was in a vacuum, it would, do that better. But it's only until you put a forced axis of rotation that doesn't line up with the center of mass that you have an imbalance situation. And obviously that's what happens in a grinding wheel. And then if you picture an entire machine in space, the relative mass of the wheel versus the mass of the grinder would determine how much each one is shaking, because the grinder would be excited by the imbalance induced from the wheel being induced into its body. If they were equal mass, they would both oscillate roughly the same amount. It's only because our grinders on Earth are, so much massively more mass than the grinding wheel that we don't even consider that. And gravity is also, holding the grinder to the ground and the tables in a lot of cases. But it's important to remember that there is no imbalance when there is no support system that is forcing it to not rotate on its axis of its center of gravity.
I'll ask him. I'll ask him. Hang on. Oh, yeah, I'll get back to you with that. Hey, listen, I just got a call from NASA, and they want to know which grinder do you want with you on the next mission that you're going on?
One with linear ways.
Well played, sir. Well played. Thank you. That's pretty insightful, and it's a good way to think about it. As you know, remove all the constraints and then put the constraints back one at a time, and then you start understanding the problem. Well, thank you, Robin. That's awesome. Anything else, or should I kick you out?
No, I know you want to keep this short.
Okay. You're awesome. Excellent. Let's see. Boom. So that was great. So balancing is important. That's basically where I was heading with this. But what happened? So this is, we're drifting into a commercial here, but stand by. The small guy, the little guy with the 6x18 or 6x12 grinder, the options for balancing can be kind of expensive. That's why I designed the balancing stand, the Kinetic Precision balancing stand, to make it as economical as possible. One of the feedback I got on that product was from a guy that said, I can't believe how much of a difference that made, because of course he was not balancing on his grinder. And even a just okay balancing job, like an 80% balancing job, will make a huge difference. And if you're careful and bring it into a 90 or 95% balancing job, it's pretty darn impressive how much nicer it gets. And to amplify something that Evils asked, at what point do you true the side of the wheel? So it's not obvious when to true the side of the wheel, but having a very out of true side of the wheel, even in a balanced condition, in other words, you take a wedge-shaped wheel, you use weights to balance it, and it's all balanced, and you can't detect any imbalance on the stand, you can't detect any imbalance on the machine, but now you start grinding with it. So now, as it grinds, it's having small engagement, large engagement, small engagement, large engagement, and that's another input to the system, and it's going to look like an imbalance. But really, and I had to learn this the hard way, really, it's the sides not being trued. So yeah, I'm a big fan of truing the sides. Even if you true, you don't have to true a lot. You just true greater than the depth of your grind. And now you've eliminated the change in engagement around the wheel. At what point in the process? So generally, when you mount up the wheel for the first time and you're doing all your things, and if you true the sides of the wheel, you probably don't have to do it again. That is the answer. Is after you've mounted it on the hub, and then you're probably okay for a while. But I think that's an important thing to do. So if you do all of those things, you do the correct truing, you do the balancing, and oh, by the way, after you true the sides of the wheel, guess what you have to do? You have to pull the wheel off and now go to balance. So there is definitely a loop here. If the last thing you should do, really the last thing you should do is true the wheel, but you should have balanced it in its as close to true condition as possible. Yeah, and of course I was only talking about grinding on the face of the wheel, not on the sides, but Robin points out dressing both sides dished is helpful / mandatory for any precision side grinding. So we would call that a relief. So, having an appropriate amount on the side if you're going to be using the side of the wheel, and then relieving a little bit is also very important. Art that makes art. Welcome, Wes. He says, my grinder doesn't have hubs for the wheels to mount to. Is there a way to balance wheels in this instance? Let's talk. because I want to understand which grinder do you have? You could just put it in chat. I have not encountered a surface grinder that doesn't use hubs. Now, I have had conversations with guys about somehow balancing their bench grinders because they were like shaking the whole bench. And I've elected to not go in that direction. Like, I don't have a good solution for that, so I don't know what to tell you. But I have not yet seen a surface grinder that doesn't use a hub. It's a tool and cutter grinder. Oh, yeah. Well, you know, those small machines, you don't have to balance them. I don't have an answer for that. You know, if you put me in that situation and said, you know, make it go, I would probably put it on the machine and true it. So now mechanically it's approximately, you know, true to the axle. I would then mark the position on the between the wheel and the axle. And then I would remove the wheel. Now it's true, but it's not balanced. And then I would put it on a balancing system, like a stand or whatever, balance it, and then go back and put it right back on in the exact same position. Tim says A-Bomb was truing his Baldor buffer hubs on the lathe. Yeah, there's tricks you can do. The manufacturers did not make this easy for us. Here's what not to do, and I will respectfully disagree with somebody who posted this to the internet. Do not whip out your carbide drill bits and start drilling holes in the side of your wheel. I have seen that offered as a method of balancing, okay? Does anybody know why you should not do that? Can anybody take a stab at it? Why should you not take a drill with a carbide bit and drill holes in the side? Yeah, Robin has, yeah, exactly. Tim understands. You're not going to. You can, A, fracture the wheel. CJ used the right word, potential unexpected separation, also unscheduled. Yeah, this could result in a wheel failure, and the person who was suggesting it in the vicinity of the hub where the stresses on the wheel are the greatest, right? The wheel is trying to pull itself apart when it spins. Yeah. Structural failure from the hoop stress, ? Unix Carbide says, stress cracks. Yes. Don't do that, please. Now. Okay, and Robin says, dressing, Dynex Hobby Impulse 2. So Robin found some really cool tools for balancing and stuff. And if you guys Google it, I think you'll find it. We should probably put it on the links page. Dynex Hobby Impulse 2. You know, in the after party, guys, remind me. I want to put this on the links page because Robin has shown this to us before, and I haven't captured it. Yeah. Okay. I think we got it, right? So, balance the wheels. That's the message. And if you don't have a way to balance the wheels, go over to the Kinetic Precision website, PFGstones.com or kineticprecision.com, and take a look at the BS8 balancing stand. It's pretty inexpensive to get yourself up and running. It's on the order of $200, and you're balancing your wheels. And I personally use the exact same tool, and that's how I balance my wheels. And I do have an Okamoto wheel balancer. And I bought that specifically to have a commercial solution to compare my balancing stand that I make and sell to, and we're doing the job in the neighborhood of $200. So Robin posted a link to dynexhobby.com, and Robin is like hashtag not sponsored, but he has the unit and it works. And he says, use the accelerometer P only. I don't know what that means yet. If you're interested, we'll post something for you. Again, we're no connection to this other company, but they do have something. And this was for the guys that make model aircraft and stuff. Is that right? Did you mention how? Okay, no, I did not mention how much the Okamoto balancing stand cost. So when I bought my Okamoto grinder, one of the, there's the options. You could buy all sorts of options. And one of the options was the Okamoto balancing stand, which looked lovely. And they want $2,500. Now, in the world of grinders and buying a brand new grinder from Okamoto, $2,500 is like, doesn't sound horrible, but it was $2,500 and I did not buy it. And then later, I started developing my own system for balancing. Long story short, that led to over 5 generations. That led to the current BS8 balancing stand. I then bought the same grinder, the same balancing stand off of eBay, unused, and it was like brand new condition for $700. Now, let me ask you a question. Let's think this one through. Why would you find an unused Okamoto balancing stand on eBay? Like never used. Somebody paid $2,500 and never balanced their wheels. It is possible that they also spent $20,000 and got the auto balancing, and then they realized they don't need this stand. I will allow for that, but basically it was pretty funny. So yes, yeah. Evil says because they bought the BS8, I can't allow for that because it was chronologically different. All right. So, believe it or not, I want to get off the topic of balancing because I wasn't planning on spending a lot of time on it, but I think we got it out there. The reason I brought up balancing is because for the, as I'm working on the lapping plates, the last step in preparing the lapping plate, or amongst the last steps of preparing the lapping plates, is to grind them flat. And this is an early picture from a week and a half ago. Okay, Robin, roger that. But I'll grab that link out of the chat, and I'll put a link in there. On the pfg.gg/links page. Thank you. And thank you for being here, Robin. Somebody pointed out that you were in a NASA colored shirt, by the way. That lovely space blue. Okay. Accelerometer P is their accelerometer. And welcome aboard, Unix, who plays bass for Balancing Act. Nice to see you. Evils asks, did you balance your laps? No, no, I did not. So after grinding the laps, of course, you look at the laps and they're gorgeous, right? Perfectly ground and wonderful. And you say, oh, they're so nice. And then if you look at the surface very carefully, you start to see grinding artifacts. I don't care how good a grinding job you did. There are grinding artifacts. And if you stone it, you see with the PFG stones, you see more grinding artifacts. So the thing that I found amazing was that as you grind or as you lap the ground surfaces, the act of lapping starts showing you even more. Like, oh yeah, this thing that you thought was like perfectly flat, yeah, it's not perfectly flat. Sorry. So the act of lapping starts to uncover all of the defects, and you know, this is a picture. Here's a picture of the client. This is a client part that actually, Robin, we do call them the shirts. That's the shirt pattern. But yes, what Robin was referring to was the groove pattern on the new plates, which of course, as you guys already know, because you're regulars here, is the aperiodic monotile. And I like to call it the shirt because it looks like an untucked t-shirt. No offense to tuck. And so here's a picture of after lapping for a bit, you could still see, look to the northwest quadrant to the left of the reflection of the light. You could see grinding marks still on the lapping plate, and to the right of it, the grinding marks are gone. Basically, the laps are showing you, they're telling you, hey buddy, you're not flat yet. So we have to keep on lapping until all of those go away, and then we know we are approaching fully lapped. So we go from grinding to lapping. Now, in lapping, what we're looking for is what I would call a first order curvature in the surface. What that means is we're going to go from maybe some curvy things going on the surface to maybe a hump in the whole plate. I call that a first order curve. There's only one place on the curve where the curve is parallel to what you want it to be, and that's it. Whereas if you have multiple humps, you know, a higher order curve, you're going to have multiple places that have that tangency that's parallel to what you really want. So grinding will get you really close to a first order curve on the lap. And then the lapping is going to start. Now you're taking the two parts, you're putting them together, and when you're all done, if they are truly lapped together, you're going to have a uniform first order curvature. You're not going to have it flat. You're going to have a uniform first order curvature. What do I mean by uniform? Well, we go around, we lap at all the different angles. So by doing that, we're eliminating any asymmetries as we go around the circle. That's an important place to arrive at. The next thing we do is we start evaluating how flat if it's the flatness we want. And I know that doesn't sound obvious, but let me show you another picture. So here's a picture of, I'm going to make it big. Here's a picture of the lap sitting on top of our turntable that we introduced last time. And on top is a holder for the client part. Okay, this is the part that we are actually lapping, which of course is 6 inches, not 8 inches. So the way we tell if the laps have the correct curvature is by measuring the workpiece. That's where the feedback loop closes. So we're going to take the workpiece, which looks like that. Of course, it's not going to be all oily, which is what this is. We're going to clean it. We're going to put an optical flat on it, and then we're going to look at it under a monochromatic light source and look at the fringes that it makes. And we close that loop, and I'll talk about how we do it. We adjust the curvature of the laps until the work tells us that it's flat. Let me say that again. We adjust the curvature of the laps until the work tells us that the work is flat. That now represents the correct curvature of the laps. And I hear what you're saying. You say, well, wait a minute, hang on. If we're making a flat part, don't we need flat laps? And the answer to that, of course, is no. The non-obvious answer to that is no. So the very short reasoning is, as you push a part on a lap, right, you're lapping the part, you're going to have more wear at the edges of the part than you are in the middle of the part. In other words, a perfectly flat lap is going to make a convex part. Okay? So what do we need? We need a convex lap. So the lap, the working lap, which is the bottom lap that you're working on, okay, is going to have a convex shape. It's going to have a hump in the middle. And then when you do your lapping of your part and pull it off, you're going to measure this perfectly flat part. It's not obvious. So you close the feedback loop. Tim says semiconductor CMP calls this dishing. Yeah, it's exactly, yeah, basically. So you're closing the flat feedback loop by measuring the workpiece. That's the most important understanding about this process. This is not the Whitworth method. Okay. This is adjacent to it, but it's not, A laps B, B laps C, C laps A, and go around the loop and they're all going to be flat. Yippee doo-dah. That is not what this is. This is, you're going to adjust the lap curvature until the part's flat. And the part flatness is what you measure. And that's how you close the feedback loop. So that's what's going on. And it's going, it's going quite well. It takes a long time to do this. It's not fast. And a lot of guys said to me, well, why don't you mechanize this? Why don't you make a machine that does it? There are machines that do this. Okay. But the machines they don't have let me put it this way. In the end, my manual process may take me less time than using a machine. Okay. Plus, we're going to bring this in for a precision landing infrequently. I don't setting up a machine to make a lens, for example. I'm looking at you, Extra Minty Matt. It takes a long time to set up the machine. And you do the same thing. You evaluate how you're doing. And then once you get the machine set up, you could make 50 lenses and they're all going to match. This is making one part. And it's always, in my case, the part is always flat because that's where it's at. Unix Carbide asks, is it fair to say Whitworth is used when the part is the thing being flattened, or in contrast, you're describing using the flat plates to act on other work pieces? Yeah. So I refer you to Ox Tools videos on self-generating flatness, okay, in which he had no flat reference at all, and he was making a flat reference. That is the essence of the Whitworth method. And he did the 3-plate method, the goal of which is to end up with 3 flat plates. And that was the so-called Whitworth method. The Whitworth said basically you could start from nothing and get to 3 flat plates. That's what Whitworth said. But that's not exactly what we're doing here. Okay, so Evil says, yeah, but how's your wrists after this with building a machine? So this is not like... When I started making precision ground stones, I was on a manual grinder. And I literally was starting to injure my left shoulder. And my advance to the Brown and Sharp grinder, and then after that the Okamoto grinder, which is a full CNC grinder, was in part because, oh no, I can't do this with a manual machine. So fast forward, here we are, and I'm doing all this manual lapping, and guess who showed up to the party? My buddy Arthur, which I don't know if any of you are familiar with Arthur. Arthur Rightus is his name. And in my family, in my genetic line, it is absolutely like on schedule. Like, oh, hello, you're over 60 years old. Welcome. This is my friend Arthur Rightus. And it shows up first in the thumbs, and in particular in your dominant thumb, in my case, right? So my right hand has been hurting, and my right dominant thumb was the point of entry. And now there's other things that are starting to bug me, but I have arthritis. And so when I'm doing, the answer to your question, Evils, is as I'm doing the lapping, you see the holders that I made for the lapping plates. Those little it turns out that those shapes are actually pretty nice, because I could put that shape in the Tim Beattie says, lap your thumb joints. It's like, I have a story about that too, by the way. It's not such a bad idea. But I have a way to hold it such that I'm pushing with the palm heel, okay? And actually I have taken the thumbs, the hand joints out of the picture as I'm doing it, but I can feel it in my elbows. I could the lapping is, I could feel it in my elbows. Like right now, I could feel it in one of my elbows. So there's no question that this is a manual process, and it is repetitive, and yeah, I could feel it. But I specifically like this particular job because I think it's going to come up about 6 times a year. Okay. This is not I'm going to be down there every weekend doing this. So I think I can handle it, but it's been an issue. And one has to consider the physiological implication of the stuff we do in the machine shop, especially when it's a repetitive action. Okay. And this is a repetitive action. That's why I'm experimenting with that slow turntable to replace some of the action, and it is working very nicely. So it's not really my wrists, but if I had to tell you the place I feel it is it's in my elbows for sure. Yeah. So Evil says, but doing it as a repeat job will hopefully be way easier than generating the lap from scratch again. Yes. So once we get these laps into play to where they're ready for the customer reconditioning job, the laps have arrived, and they are not going to need all this work next time. So that's the nice thing. But getting these laps into shape is takes energy. Would I like a Lapmaster machine that allegedly does a bunch of this stuff? I would love to play with a Lapmaster machine. I'd love to have one, set it up, have it lap things, adjust it, see what the adjustments do. I think that would be a really cool thing to do. And one of these days I'll trip over a small one and might even just grab it. Yeah, so laser recrystallization for my thumb joints. Ooh, that's a good idea. I'll tell you the story at the end about recrystallizing my thumbs. So you bring up a good point, Evils. A machine takes up floor space, right? So now if I say I'm going to go get a Lapmaster, it doesn't matter what size it is. That's a footprint, and that footprint has to fit in the shop, and it has to earn its clutter credits. Okay. I've thought about this. So I don't, I'm a little nervous about spending clutter credits on a machine to do something that I could do manually 6 times a year or whatever, right? But I would like to mess with it. I would like to learn from it. Maybe I could find one and get it into our makerspace. I don't know. We'll see what happens. But I know they made some little weenie ones, and that would be kind of fun. But I'm concerned about clutter credits. See previous videos on clutter credits. Anyway, so that's the story. That's where we're at on lapping. Very excited to get that guy going. But we will not serve up any laps on a customer part until it's time. And it's getting close. It's getting mighty close. You guys have any questions or comments or strange remarks? You could post them to the chat right now. Otherwise, we're going to bring this in for a landing because it is the top of the hour. I think I need a sip of tea, so let's just listen to some PFG Stones while I do that. Thank you very much. Evils is also interested in a slow speed grinder that can be used as a lapping machine for up to a 60 millimeter optical flat. Yeah, I think it would be fun. And I think getting that dialed in would be kind of cool. And Extra Minty Matt, if you're listening, I'd like to have you on as a guest. And we could talk about what the optical guys do because I'm very interested. But this is coming in, and we will see what happens. It was amazing to me as I thought about what we do with very, relatively little equipment, right? Optical flat, monochromatic light source. We're down measuring in the half micrometers, basically. Actually, below that. We're detecting tens of nanometers in terms of surface. And that's with crude stuff. And Zygo interferometer would be welcome. Do you hear me, Zygo? My neighbor to the south. We'd even feature you on the channel. Anyway, with that, I'm going to wrap it up. You guys are awesome. Thank you for sharing. This community is awesome. Let me just say something that I'm not going to give details, but you guys have helped out members of our community in ways that I am gobsmacked by. And I want to just say thank you very much. Get flat, stay flat. I mean, really flat. We'll see you guys next week. Take care.